Good morning, students. In the last class, we have we had a discussion about the new module, that is gear train, and so many things right from the beginning has been discussed. So before moving on to the numericals, if we recall what we had a discussion in the last class, that is the summary or a review of the last class. I started first by defining what is a gear train. So what is a gear train? It is a combination of two or more gears meshed with each other to transmit power from one shaft to the another shaft. I defined the gear train like this. As the name implies, it consists of different types of gears: spur gear, helical gear, bevel gear or spiral gear. And also for certain application or for any certain application, how the gear train, a suitable gear train can be selected. It can be selected based on two factors. One is how much is the required velocity ratio, and the other one is the relative position of the axis of the shafts. So these are the two things based on which one can choose a suitable kind of gear train for any application. Then we just talked about the different types of gear trains. As I said very clearly, that based on the arrangement of the gears. So in general, the gear trains are four types. One is simple gear train, second one is compound gear train, third one is reverted gear train, and fourth one is epicyclic gear train. So what is simple gear train? If one shaft is supporting one gear, if only one gear is mounted on each shaft and there is no relative motion between the axis of the shaft, then it is called as a simple gear train. Understood? If only one gear is mounted on each shaft, or the shafts are supporting only one gear and there is no relative motion between the axis of the shafts, then it is called as a simple gear train. And second one is a compound gear train. In compound gear train, more than one gear is mounted on a shaft except the driver and the driven. Except the driver and driven. If any shaft in between a driver and driven are supporting more than one gear, then it is called as a compound gear train. But these are the two types of gear trains which we have discussed in the last class, and how to find further the velocity ratio or the speed ratio, or it is also called as a gear ratio, for these two types of gear trains. One is simple gear train, another one is compound gear train. Now, what is velocity ratio? So, velocity ratio in general is the ratio of the speed of the driver to the speed of the driven. So velocity ratio means it is speed of the driver to the speed of the driven. That is equal to the reciprocal of the ratio of the reciprocal of their teeths. That is number of teeths on the driven by number of teeths on the driver. So like that, simple, in a easiest way, how to remember. If I have a simple gear train having two gears, one is driver, another one is driven. If these two are directly meshed with each other to transmit a power from one shaft to the another shaft, then the velocity ratio is equal to, that is, ratio of speed of the driver to the speed of the driven. That is equal to ratio of the reciprocal of their teeths. That is, number of teeths on the driven by number of teeths on the driver. Now, if I look at the slide which is right in front of you, I have drawn a simple sketch of a simple gear train where we have two gears which are represented by means of a pitch circle diameters. There is no teeth, nothing. So generally in a diagram, in the schematic diagram, we represent the gears by means of their pitch circle diameters, simply by means of one circle. Like that here, simple gear train in that first figure A, in which there are two gears which are meshed with each other to transmit a power from the shaft 1 or gear 1 to the gear 2. In this, gear 1 is driving the gear 2, therefore gear 1 is called driver. Gear 2 is being driven by gear 1, therefore gear 2 is called as a driven or a follower. Like that, here there are two gears, one is a driver and another one is a driven or a follower. For this, simply the velocity ratio is equal to, what is the formula? That is, I said ratio of speed of the driver. Speed of the driver is N1. Here driver is gear 1. So therefore N1 by N2, that is the speed of the driven. So N1 by N2 is nothing but velocity ratio. That is equal to what? That is equal to ratio of reciprocal of their teeths. That is equal to number of teeths on the driven. That is nothing but T2. And number of teeths on the driver, that is equal to T1. Therefore, in a simple gear train, if we have two gears, 1 and 2, velocity ratio formula is equal to N1 by N2 is equal to reverse T2 by T1. Similarly, when the distance between the driver and the driven are far away, or when there is a gap in between the driver and the driven, between which I would like to transmit a power, then I can use the intermediate gears. That we called it as ideal gears. Now if I look at the figure B, it is also a simple gear train, but in between the driver and the driven there is one intermediate gear. So in this case, the velocity ratio, again it is same, because in between driver and driven, if I put one intermediate gear or 2 or 3, any number of intermediate gear, it does not affect the velocity ratio. Any number, let it be any number of intermediate gears or ideal gears in between the driver and the driven, because main is what? I want to transmit a power from driver to the driven, but in between there is a gap. I just filled it by means of ideal gears or intermediate gears. But if I introduce any number of intermediate gears, if there is 1, 2, 3, if there is a gap, still I can use even 10 number of ideal gears. But it does not. The ideal gears are only used in order to fill or bridge the gap in between the driver and the driven, where we would like to transmit a power. In between driver and driven. Therefore, irrespective of number of ideal gears or intermediate gears in between driver and driven. Now, if I take the figure number P, there is only one intermediate gear. I named it as 2. So, gear 2 is a ideal gear or intermediate gear. Gear 1 is a driver. Gear 3 is a driven. So, now for this simple gear train having one intermediate gear, once again the velocity ratio is equal to N1 by N3, because ratio of speed of driver, here speed of the driver is gear 1, therefore N1, by speed of the driven, that is nothing but gear 3. So therefore N1 by N3 always, that is equal to reciprocal of their T's, means number of T's on the driven, that is T3, by number of T's on the driver, that is T1. Like that, first and last, in between let it be any number of intermediate gears. So N1 by N3 is equal to T3 by T1. Like that, if I take the figure number C, now gear 1 is a driver gear, gear 4 is a driven gear. In between, I would like to transmit a power, but there is a gap. I have provided two intermediate or ideal gears. They are named as 2 and 3. So now here number of ideal gears or intermediate gears are 2 in between driver, that is gear 1, to the driven, that is gear 4. Now in this case also, once again the velocity ratio is equal to speed of the driver, that is gear 1 N1, by speed of the driven, that is N4, which is equal to ratio of reciprocal of their T's, that is number of T's on the gear 4, because driven, number of T's on the driven, that is nothing but gear 4 in figure number C. Therefore T4 by T1, number of T's on the driver, that is the gear 1. Like that, you can remember simply a velocity ratio formula like this. If there are only driver and driven, N1 by N2 is equal to T2 by T1. If I have intermediate or ideal gears of any number, 1, 2, 3 and so on, but always remember the velocity ratio formula is in between first and last, because driver and driven, because the ideal gears does not affect the velocity ratio, even though any number of gears in between a driver and a driven. Therefore, in first figure A, N1 by N2 is equal to T2 by T1. In figure B, N1 by N3 is equal to T3 by T1. And in figure C, the velocity ratio is N1 by N4 is equal to T4 by T1. Like that, one can remember the velocity ratio, how to find the velocity ratio in case of a simple gear train. Now, in the last class, also we have discussed about the second type of gear train, that is a compound gear train. So, what is compound gear train, students? So, compound gear train means except the driver and the driven, in between, if more than one gears are being mounted on a shaft, or in between a driver shaft and a driven shaft, so any shaft in between these two are carrying more than one, supporting more than one gears, then it is said to be a compound gear train. Now you see, in compound gear train, because overall objective here is to find the velocity ratio. If you find the velocity ratio, then I will come to know so the speed of the any given shaft, any unknown shaft, right? Once the speed is known, with that you can calculate the torque, and then further at the end how much power your gear train which is being designed for a certain applications can be transmitted. So overall here idea of undergoing a gear train is to find a velocity ratio, further followed by if required torque and power also. Now in case of compound gear train, now if I look at the first figure in compound, so here in this, because how this first figure can be called as a compound gear train, because here I named with the alphabets A. A means it is gear A, which is said to be a driver. Gear D is said to be a driven or a follower. In between a driven, driver and a driven means in between A and D there is one shaft which supports the two gears, that is named as B and C. So on this shaft B and C are the two gears which are being supported on only single shaft, means this shaft is carrying more than one, that is gear B and C. Therefore this is said to be a gear train, right? In this gear train, how to find the velocity ratio? Once again, it is ratio of speed of the driver. Here you look at A is driving the gear B, therefore gear A is called a driver. Then when B rotates, as the gear C is also mounted on the same shaft, gear C also rotates in the same direction with the same speed, and that gear C drives the gear D. So therefore here in this compound gear train there are two drivers. One is gear A, another one is gear C, because gear A is driving gear B, therefore gear A is first driver, and gear C is driving the gear D, therefore gear C is also said to be a one more driver, where we call it as second driver. Like that here there are two drivers, gear A is first driver, gear C is the second driver. Next, B is said to be, anyhow you people know that gear D is a driven gear. Now in addition to D, here we can find one more driven gear, because A is driving a gear B, therefore B is said to be a driven. So B, gear B, gear D are two drivens. So it is B is a first driven, D is a last driven. So now in case of compound gear train, ratio of velocity ratio is NA, speed of the first driver. Speed of the first driver is NA by speed of the last driven, that is ND, because A is the first driver, C is the second driver, and gear B is a first driven, gear D is a last driven. So now the velocity ratio is NA, speed of the ratio of speed of the first driver to the speed of the last driven, that is D. So NA by ND is equal to ratio of product of number of teeths on the drivens. Here how many drivens are there? B and D. B and D. So TB into TD, number of teeths on the gear B into number of teeths on the gear D, divided by the product of number of teeths on the drivers. Here how many drivers? Gear A and gear C. Therefore TA into TC. So like that one can remember a velocity ratio in case of a compound gear train. So once again I repeat, in this compound gear train, velocity ratio is speed of the first driver, that is NA, by speed of the last driven, that is ND. So NA by ND is velocity ratio. That is equal to what? That is equal to product of number of teeths. Product of number of teeths on drivens. Here there are two drivens, gear B, gear D. Therefore, number of teeths on gear B, that is TB, into number of teeths on the gear D, because B and D are driven pulleys, driven gears, divided by product of number of teeths on the drivers. Here there are two drivers, gear A and gear C. Therefore, TA into TC. Like that one can remember in a blind way a velocity ratio in case of a compound gear train like this. Similarly, if I take the next figure of the compound gear train, here gear A is a first driver and gear F is the last driven. First driver is A, last driven is F. Now in between first driver to last driven, there are two compound gears. B and C mounted on the same shaft, they are rotating in same direction with the same speed. Similarly, D and E are mounted on the same shaft, rotating in the same direction with the same speed. Therefore, BC is one compound gear, DE is one more compound gear. In between, there are A and F. A is a driver, first driver, and F is a last driven. So now, can you please tell students, in this figure, how many drivers are there? Totally 3 drivers. What are they? Gear A, gear C, and gear E. Because gear A is driving gear B. Gear C is driving gear D. Gear E is driving gear F. Therefore, gear A, gear C, and gear E. All these 3 are said to be 3 drivers, in which A is the first driver. Next, here F, you know that it is a last driven. But there are 2 more, totally 3 drivens. What are they? B is being driven by A. So B is one driven gear. D is being driven by gear C. Therefore, D is also a driven. And F is being driven by E. Therefore, F is also one more driven. So, like that, there are totally 3 driven gears. B, D, F. But in this B, D, F is said to be last driven and A is said to be first driver. So now in this gear train, the velocity ratio is simple always, first and last, that is speed of the first driver, that is NA, by speed of the last driven, that is NF, is velocity ratio. That is equal to what? Product of number of teeths on the driven gears. How many driven gears? 3. B, D, F. Therefore, TB into TD into TF divided by product of number of teeths on the drivers. How many drivers are there? A, C, E. These 3 are driver gears. Therefore, TA into TC into TE. Because this is the summary of the last class. So, why actually I took around about 20 to 25 minutes, as the gear trains has been started in the last class itself. So, I thought of it is better to revise and how to remember, so that it is not only a recalling of the last class. So, I want to just make you people to remember the ways of the velocity ratio in case of simple gear train and a compound gear train. So now I hope you people have understood not 100%, 70 to 80% of from this summary. So not only a first class, now today with this summary, I hope we can proceed to a simple numericals. Now taking a first problem, it is the problem given on a compound gear train. Now look at the first problem. I am just reading the statement. A compound gear train shown in figure consists of gears B and C and D and E. The motor shaft rotates at 1000 rpm, 1000 rpm, and it is connected to the shaft of gear A, and the output shaft is connected to the gear F. So calculate the speed of the gear F, assuming that the gears are mounted on the parallel shaft. This is the statement, and followed by this is the figure. Now with the summary what I told, now I hope the students can, I hope you people can now identify with the figure, is it a simple gear train or a compound gear train? Am I correct? Yes, it is a compound gear train. Right. It is a compound gear train. But how many compound gears are there? There are two set of compound gears. One is BC, another one is DE. These two are mounted on the same shaft. See, gear B and gear C is said to be one compound gear which is mounted on one shaft. So gear D and gear E both are mounted on the same shaft. Therefore, this is one more compound gear. So there are two compound gears in between the first driver, that is gear A, and the last driven, that is gear F. Now the motor shaft rotates at 1000 rpm and it is connected to the shaft of gear A. So gear A, for which the gear A is mounted on the motor shaft, and that motor shaft itself is rotating at 1000 rpm. Therefore, given things, if I list out here, speed of the gear A is known, that is NA, which is equal to 1000 rpm. Because how I can say gear A is connected to the motor shaft, and that motor shaft is rotating at a speed of 1000 rpm. So definitely the motor shaft is supporting gear A. Therefore, gear A speed is equal to 1000 rpm. Therefore, NA is equal to 1000 rpm. And the output shaft is connected to the gear F. Now I can understand the gear A, which is connected to the motor shaft, is a input shaft, and output shaft is connected to the gear F. Calculate the speed of the gear F. That is, I should find NF is equal to what? So what is given thing? It is a compound gear train having two compound gears. One is BC, another one is DA. And gear A is said to be a motor shaft or a input shaft, or in our terminology, first driver. Gear F is connected to the output shaft, but its speed is unknown. That we have to calculate. So now in our terminology of gear train, so now gear F is said to be what? Last driven. A is first driver and F is last driven. Now given is NA is equal to 1000 rpm, NF is equal to be calculated. In addition to this, I know the number of T's on the gear A, that is TA, is equal to 24. Number of T's on gear B is 56. On gear C, that is TC, is equal to 30. Number of T's on the gear D is, that is TD, is equal to 80. number of T's on the gear E, that is TE is equal to 32, number of T's on the gear F, which is a output gear, so that is TF is equal to 72. So T's of all the gears in the given compound gear is known, first point. Second point, speed of the gear A, that is the first driver, NA, is known, which is equal to 1000 RPM. I should find the speed of the gear F, which is connected to the output shaft. Now to find NF, so let us write down the velocity ratio which I told just now. So velocity ratio, or it is also called as a speed ratio or a gear ratio. In case of what type of gear train? Compound gear train. You write down here, speed of the driver means first driver by speed of the driven, that is speed of the last driven, that is equal to product of number of T's on the drivens. Sorry, here you please correct it. Product of number of T's on the driven by product of number of T's on the drivers. So that is NA by NF. So speed of the first driver is NA by speed of the last driven is NF. So NA by NF is equal to product of number of T's on the drivens. So here drivens are gear B, gear D and gear F. Therefore, TB into TD into TF divided by now product of number of T's on the drivers. Here how many drivers? 3 drivers. Gear A is first driver, then gear C is a second driver, and gear E is a third driver. Therefore, TA into TC into TA. Then further NA, it is known, substitute 1000 divided by NF, that is speed of the gear F, which is unknown, where we have to find, that is equal to number of T's on TB is 56, TD which is given as 80 into TF which is given as 72 divided by TA is 24 into TC is 30 into 32. If I substitute, after substituting only unknown is NF, that if I simplify, it will be coming around 71.4 revolutions per minute. So here because of here that there are 2 compound gears, so gear A is rotating in clockwise direction. So obviously because of the even number of compound gears in between, so the rotation of the gear F will be in the opposite direction. Therefore, NF is rotating in the opposite direction of the gear A with a speed equal to 71.42. So similarly, second problem, once again, here there are, if I read the statement, the gearing of a machine tool is shown in figure. So this is the diagram. The motor shaft is connected to gear A and rotates at 975 RPM. The gear wheels BC, B, C, D and E are fixed to the parallel shafts rotating together. The final gear F is fixed on the output shaft. So what is the gear? What is the speed of the gear F?